I am Anil Kumar. Welcome to my series on solved test papers. I have taken up many important test papers from previous years to share with you so that you can practice and get better marks. Let me thank all my students for sharing these test papers with me. In this video, we'll discuss a test paper on calculus where we have trigonometry and its applications. So let's go through these questions one by one. You can always pause the video, copy the questions, try them out, and then look into my suggestions. Now this test paper may take about an hour since I may like to explain you a few points in between. So once you know the technique, you should be in a position to solve this 75-minute test paper in less than an hour. Question number 1, differentiate the following, simplify fully. That it's important to simplify these given functions. Question number 2 is just to find the derivative of a composition of trigonometric functions. Question number 3, using second derivative test, determine all local extremas, maximums and minimums for the given function in the domain 0 to 2 pi. Now question number 4, determine the x-coordinates of all the points where slope of the tangent line for the given curve is horizontal, that is, slope is 0. Question number 5, if y equals to sine x over x, show that x d2y dx square plus 2 dy dx plus xy equals to 0. Now this is a very lengthy solution for this one, so you may have to take 5 minutes to solve this question. Question number 6. Determine the equation of the normal to the curve square root 2 sine x plus y equals to 0 at 0 pi by 4 expressed in standard form. The equation of normal, right? So it is based on implicit differentiation, right? Now here are other application questions. Question number 7. An observer watches a rocket launch from a distance of 4 kilometers. The angle of elevation theta is increasing at pi by 40 radians per second at the instant when theta is pi by 4. How fast is the rocket climbing at that instant? Question number 8. The depth of water D in meters of a seaside pier can be modeled by the function d of t equals to 3 over 2 cos pi t by 6, where t is time in hours. Determine the rate of change of the depth of water with respect to time at 3 hours. Question number 9. A particle moves along a line so that at time t in minutes, its position in meters is s of t equals to 8 sine 2t. For what exact value of t does the particle change direction in the interval 0 to pi? What is the particle's maximum velocity in the interval 0 to pi? Now when we talk about maximum velocity, you need to actually show it as we do in calculus, right? So that is kind of important to understand. So I hope you understand all these questions and you find them useful. Feel free to pause the video, solve them while we go through these solutions, correct? So let's begin with the very first one, which is to differentiate the following functions. So I've changed it a bit. So I'll be only simplifying part A and B. So part C and D I've clubbed with the second question. Okay. So let's see how to differentiate and simplify. You need to review trigonometric identities and all the formulas which you have learned to do this paper. So that is kind of very important for you to understand, right? Now we have this function which is f of x equals to 2 sine square x minus 2 sine to the power of 4x. We need to differentiate, that is to say f dash x. So we can use the chain rule to differentiate, correct? So the first term, it is 2 times 2 sine x times derivative of sine x, which is cosine x, correct? Minus here 2 times 4 sine cube x. We have used the power rule, correct? Times derivative of sine x, which is cos x. Now 2 sine x cos x is sine 2x. right? So we could write this as sine 2x. Or what we can also do here is that now this second part, which we have here as 2 times 4 sine cube x times cos x, we can actually take cos x common, right? So let's do that. So what we will do here is, to simplify, we'll take sine x cos x times 2 as common, right? So we can take 4 also, right? So we can take 4 times sine x cos x as common, and we're left with 1 minus. So we've taken 4 outside, 2 sine square x, right? So cos x has been taken common. Now 2 sine x cos x is sine 2x. So we could write this as 2 times sine, or let me write like this. Okay, just going through these steps. Now, what is 1 minus 2 sine square x? 1 minus 2 sine square x is actually cos 2x. So I hope you remember these formulas. That's kind of very important. So let me write down these formulas here before I write down the final solution. So we have cos 2x equals to cos square x minus sine square x, which could also be written as 2 cos square x minus 1, and it's also equals to 1 minus 2 sine square x, correct? And sine 2x is 2 sine x cos x. So we are going to use these formulas, and that's why I was just breaking it down into sine 2x cos x. So now I will write this as 2 times sine 2x, correct? And this term here, 1 minus 2 sine square x, is actually cos 2x. So what we get here is 2 times sine 2x cos 2x. So I hope you understand and appreciate this part, correct? So simplification is key in this particular question. Derivative may be simple, right? Now let's do the derivative of this particular function. Now let's say g dash x. You could actually simplify this and then do the derivative. So you could do that also. So some of you can actually simplify the function, write this as sine x over cos x times cos x, and then you are left with sine x, correct? So you could say g of x is sine x, and therefore the derivative of this function is basically cos x, correct? You could do that. But many of you will actually apply the product rule to do the derivative, correct? So let's do the product rule also. So tan x derivative is secant square x. So we can say g dash x is equal to, okay, so secant square x times cos x plus tan x times minus sine x, correct? So that is the derivative of cos x. Now secant square x is 1 over cos square x times cos x plus tan x is sine x over cos x. And this is, I should have written minus here. Okay. Now as you can see, one of these cos cancels. We have cos in the denominator, and the numerator is 1 minus sine square x, correct? Over cos x. Now 1 minus sine square x is cos square x over cos x, and that also gives you cos x. Perfect. So the derivative for this function is cos x. You get the idea. So the key here is to differentiate and simplify. That's what I want to lay more stress on. Now let's look into the other 3 examples where we are going to use different rules to find the derivative, correct? Now here, the derivative of the function will be 2 times sine square root t, right? We are differentiating with respect to t this time, times the derivative of square root t, which is 1 over 2 square root t. Correct? Times the derivative of the sine square root t, right, which is cos square root t. Do you understand this part? So what we have to do is to find derivative of inside functions, and we basically have applied the chain rule to solve this, right? So I'm giving you in short just the kind of solution to it, right? So 2 and 2 we can, or we need to simplify. So sine t cos t square root t, we can write this as sine of 2t, right, when you simplify. Is it okay? So we could write this as this numerator as sine 2 square root t over 2 square root t. Is it okay? Now you may rationalize and also write, you could do that, but I have really removed that part here, so I written do not simplify. But you should practice how to simplify and write down your answers. So I hope you get the concept, correct? So that is how we could work with it. Now here we'll apply the quotient rule. So we get in the denominator 6x whole square, which is 36x squared. Derivative of this part, which is 4 cos cube 3x, times derivative of cos 3x, which is minus sine 3x, times the derivative of 3x, which is 3, right, times 6x, which is 6x, minus derivative of 6x, which is 6, times cos to the power of 4 3x. Is it okay? Right. So I'll leave the simplification for you to do on these questions, correct? The last one here, I should write y dash equals to. Okay. Now the derivative of this function f dash x. Now in this particular case, we have to work inside, right? So sine of all that will be, derivative will be cos of all that, which is cos of x squared. Perfect. Now times the derivative of inside function, which is cos x squared, right? So cos x squared derivative will be minus sine x squared, right, times the derivative of x squared, which is 2x. You get the idea. So that is how you have to find the derivative. So this time we had a chain rule. Perfect. So you may simplify these questions, solutions, right? Here is question number 3. Now we need to use the second derivative test and determine all local extremas. So local extremas means what? We have to equate first derivative to 0, right? So first derivative for this function will be cos x minus, now cos x derivative is minus sine x, so let me write this as sine x. Derivative of 6 is 0. Now for extrema, what should we do? We have to equate the derivative to 0. So we get 0 equals to cos x plus sine x. So that basically means that we can write this as sine x rest, that means tan x, right? So let's write this. Sine x equals to cos x. Now dividing by cos, we get, if I divide this, let me show you here. Minus, right? So if I divide by cos x both sides, in that case, what do I get? I get tan x equals to minus 1, right? So in this interval, 0 to 2 pi, tan x is minus 1 in quadrant 2 and 4, right? So we get the value of x, which is the acute angle here is pi by 4, right? So this is pi by 4. So this is 1 pi by 4 to 3 pi by 4. Correct? 4 pi by 4, 5, 6, 7 pi by 4, or 1 less than 8. So these are the two critical points which we get. Right? So when we say using second derivative, determine all local extremas. So we could have actually also find the value from here. We know the critical numbers are at 3 pi by 4 and 7 pi by 4. But since the question says using the second derivative, so we have to find the second derivative, correct? So let's find the second derivative, and we get minus sine x plus cos x, correct? So equating now second derivative test. So in second derivative, we have to check these two values. So let's write down the critical values. That are at x equals to 3 pi by 4 and 7 pi by 4, correct? Now, which is in quadrant 2 and in quadrant 4, correct? So let's check the second derivative. So at minus sine 3 pi by 4 plus cos 3 pi by 4. Now, in second quadrant, sine is positive, so you get 1 over square root 2, okay? And for cos, it is negative, so you again get more negative, correct? So we know this is less than 0. So that means the second derivative at this point, being less than 0, is concave down, right? So this is concave down. So that means we have maximum at 3 pi by 4, correct? You get the idea? That is how you're going to do. Now let's test the other point, which is 7 pi by 4 in the same derivative. So minus sine 7 pi by 4 plus cos 7 pi by 4. Now 7 pi by 4 is in quadrant 4. Here sine is negative, so negative will make it positive. We get 1 over square root 2, and cos is positive, so we have a value which is greater than 0. Since it is greater than 0, in this case the curve is going to be concave up, right? So it is going to be concave up. So what do we have here? We have local minimum, right? So at x equals to 7 pi by 4. Is that clear to you? So that is how you're going to solve and explain your answer for question number 3. So I hope the concept is absolutely clear. Let's move on and take up question number 4 now. Question number 4. Determine the x coordinates of all the points where the slope of the tangent line to the given curve in the interval 0 to pi is horizontal. So we are given the function y equals to sine x cos cube x in the interval 0 to pi. So horizontal means derivative should be 0, right? So let's find the derivative first. Applying the product rule, we get this as cos x times cos cube x, right, plus sine x times derivative of cos cube x, which is 3 times cos square x times cos x derivative, which is minus sine x. Now we can take something common, which is cos square x we can take common. So we get here cos square x minus 3 times sine square x, right? So this is 3 here, so 3 times sine square x. Now for the critical numbers, now critical number is what? In this case, we want horizontal tangent, right? So the tangent line is horizontal. So that means y dash should be 0 for horizontal tangent. Is that clear, right? So let's find the value. So one value could be, so for y dash equals to 0, we have cos square x equals to 0. That is one option. Second one here is that cos square x is equals to 3 sine square x. Now this second option will give us 1 over 3. And we have tan square x, so let's write tan x and make it square root with plus and minus. Does make sense? So these are the two options for you, right? So when tan x is this, so let's use our special triangles to figure out the answer. So this special triangle, as you know, here we have square root 3, right? 1, 2. So tan is 1 over square root 3. That means we're looking from this side, 1 over, which is pi by 6. So pi by 6 in all quadrants, in all 4 quadrants. So pi by 6 here and pi by 6 there. So that is what it is. Since the interval is from 0 to pi, so we get the value of x as equal to pi by 6 and 2 pi by 1 less than pi by 6, which is 5 pi by 6. Right. As far as the cos zeros are concerned, they are at pi by 2, right? So this is at x equals to pi by 2. Correct? So these are the solutions where the tangent line will be horizontal. So we get an answer as x equals to pi by 2, pi by 6, and 5 pi by 6. Since we are working in the interval 0 to pi. I hope that's absolutely clear, right? Question number 5. If y equals to sin x over x, show that x d2y over dx squared plus 2 dy dx plus xy equals to 0. You can actually pause the video, answer this question, and then look into my suggestions.